Okay. So there might be another error that should.
सपने में रात ने आई, सपने में रात ने आई, सपने में रात ने आई वकर की छाड़ा रे तेरे मिला के नाम तू सुनारा रे मन तेरे मिला के नाम तू सुनारा रे। उसका तो रूप निराला था, दिल ढोती ऊपर काला था, मैं देख के पागल हो गया, बड़ी मुश्किल होश संभाला था।
Okay, so we are live. So hello guys, we are live. The live is started and we will. I'm just updating the thumbnail. So I'm just updating the thumbnail, and after updating the thumbnail, we will start with our project today. Till then, you can listen to some Haryanvi music.
तेरी खातर लाया सुकमा के छोरी देख ले तू अजमा के तेरी खातर लाया सुकमा के छोरी देख ले तू अजमा के ना कर मरो तेरे पे मैं कर दूं खर्च करोड़ तेरे पे मैं कर दूं खर्च करोड़ तेरे पे मैं कर दूं खर्च करोड़। जो राधा ने पाया श्याम में जो सीता ने पाया राम में मेरे जैसा न पावे गाम में जब बंधूंगा मोह तेरे पे मैं कर दूं खर्च करोड़ तेरे पे मैं कर दूं खर्च करोड़ तेरे पे मैं कर दूं खर्च करोड़। जान मेरी से जान ले तू प्यार मेरा पहचान ले तू बात मेरी या मान ले फिर पटन दे तो।
ये सुनो भाई, ये सुनो। कोई नहीं सुन रहा अभी, पता है मुझे, बट 2 मिनट बस तेरे लिए।
भीगी भीगी पलके मेरी उदास तेरे लिए हो जागी जागी सोई ना मैं सारी रात तेरे लिए भीगी भीगी पलके मेरी उदास तेरे लिए अखियां बिछाई मैंने तेरे लिए दुनिया भुलाई मैंने तेरे लिए
जन्नत सजाई मैंने तेरे लिए छोड़ दी खुदाई मैंने तेरे लिए जन्नत सजाई मैंने तेरे लिए छोड़ दी खुदाई तेरे लिए जो मैं दीवाना बन के तेरे लिए वादा है मेरा मैं हूँ तेरे
Yeah, we are live and I updated the thumbnail. It's been 6:27. Okay. So the live stream starts at 6:30. And so what will be the goals of today's live stream? So for today, we just did not perform any of these goals yesterday. So we will do them today. And today we have a very ambitious goal, I would say, because today we will beat the caddy server in raw performance. And to show you what caddy server is, it is a reverse proxy, and it can be used for a lot of things, but majorly it is used for reverse proxy, and it has around 73.5 thousand stars on GitHub. So this is like pretty big project. It's been from 4 years, built and developed from 4 years. It has 402 contributors. So around 400 people contributed in this thing. So this is a pretty big project. As compared to this, let me show you my repository. Mm, let's go here, repositories. And this is our repository Cachify, which has only one star, and I starred it. And it was started around 2 days ago. So this, as you can see, this is a very ambitious goal. But being ambitious is okay because the people at caddy are also humans, and we are also human. And if we think from first principle, because there is no magic in these things. If you think from first principle, then you can do anything, I guess. You can even build your own Linux from scratch if you have enough time. So let's go. Pretty ambitious goal for today. So okay, so let's just compare the performance of caddy server. So let me just open a terminal. And from yesterday's video, you can just know that this Hey tool, we are using this tool to load test our reverse proxy. So first, let me just start the caddy server. So how to start the caddy server? It has a caddy file, which is kind of a config file, and we have here like listen on 3000 and reverse proxy to localhost 8080. Exactly what we are doing. So this will do the same thing. Okay. And the command to run the caddy server was curl code aja 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 aja. So nahi aayi. Okay. Maybe it was here. Yeah, it's here. So so this is the command to run the caddy server. So now this server is running the same as our reverse proxy. So let me just show you by going to localhost 3000. Again, the secure connection error. But today we know why it is coming. So yeah, because we have to use HTTP because currently we are not supporting HTTPS. Okay. So this is the same thing as our reverse proxy. And now we will compare how this thing hold up. And also I looked at the code of main server and there was a console line here, fmt.println, a request came. So there was this line here and it was causing a lot of delays, I guess. Because if I remove this line and then load test this backend server, then you can see how much request per second it will process. So it is processing around 60,000 requests per second. So this is pretty good. And yesterday we were only at around 26,000 requests per second. So basically I improved my backend a bit, and because this was unnecessarily, because what was happening is there was like a lot of console.line, a request came, a request came, a request came. But we don't need this thing. So I removed that. We needed that in the development phase to know that a request was coming to the backend, but now we don't need it. and it was slowing down our backend. So our backend is currently running at 60,000 requests per second. Okay. So now let's just test with caddy. How much request per second can it perform? Can it even outperform our backend? It will not outperform our backend, but let's see how much it will do. Okay. So as you can see, it is doing only 16,000 requests per second. So this is pretty low, I guess. Okay. So maybe I should clear some things on my computer before doing this because this is pretty low. I did not expect it to be this low. So let's just ask ChatGPT if this is okay or not. Okay. Because I expected it to drop to around 50,000 requests or 40,000 requests per second, but it is dropping to 16,000 requests per second. So I ran a simple caddy reverse proxy. The backend was giving 60k request per second, and caddy is giving 16k request per second. Is it normal or not? Yes, that's actually quite normal. Here's why. 60,000 reverse proxy. This is introducing three. A reverse proxy has to do several things. Pass the HTTP request, apply middleware, logging, routing headers, forward the request. Okay, CAD is designed primarily for okay. A few things to verify. Are you benchmarking? Are you using reverse proxy or something more complex? Are access logs enabled? Is compression enabled? Is benchmark running on localhost? So let's just write a caddy file with everything disabled and just a simple reverse proxy HTTP. Okay, so yeah, so this is the file it has given me. So what I will do is copy and paste it here and let's just rerun our caddy server because maybe caddy was doing a lot of things and we don't need to do those things for comparison basics for comparison because our reverse proxy is not doing a lot of things. Our reverse proxy is just accepting and forwarding. It's not doing HTTPS, it's not doing any logging, it's not even parsing the HTTP request. So the comparison should be fair. So let's see how caddy performs here. Okay, so it ran. Now let's just clear this thing and load test it again. Mm, okay, so it's still giving 16,000 requests per second. So as you can see, I gave caddy everything it wanted. I removed every setting I could, and it's still giving around 16,000 requests per second. So now let's just write some things down. So for caddy, it was from 60k requests per second to 16k requests per second. So that's around calculator. So that's around 4, 3.5 to 4. Let's just divide. Okay, I'm getting nervous in the life. Okay, so it's just 3.75 times slowdown. So let's just write the slowdown here times slowdown. Okay, and yesterday our reverse proxy was let's just name it Cashify version 1. So as you can remember, when we ran 1,000 requests, it was giving around 40 requests per second. And the backend yesterday was giving around 26,000 requests per second. Uh, and 249 requests per second, which was pretty bad. But I made it intentionally bad because I wanted to. Okay, so let's also calculate this thing. Calculator. Let's just find out how much of a slowdown is it. Divide by. Okay, so we need to divide 26,000 with 49. So this is 530 times of slowdown, which is huge times slowdown. Okay. So this was our condition in the previous video. So I made it intentionally bad because this code is like very easy to understand. And from this code you guys could understand like how a reverse proxy works. Because in the first version, if I would have written everything using Go routines and channel and made it optimized and everything, then you guys would not have understood like what I was doing. So this code was, I would say, pretty good to understand because everything is sequential. Nothing, there is no complexity in this code, as I can see. So, but today we will try to beat the caddy server. So we need some complexity for that. We cannot beat caddy server without introducing some complexity. So let's go, I say. Uh, okay, so let's just study a few things about Go routines and channels because we will need these things today. To beat the caddy server, we would need some Go routines and channels because without that, we cannot beat it in a sequential manner. We just cannot. Using an infinite for loop, we just can't do this thing because everything will be sequential. So it's just impossible to do that. So let's study some things now. Okay, I know that Go is a programming language. Are lightweight thread of execution that are managed by Go runtime. They are cheap to create and can run simultaneously with other Go routines within the same process. You can think of them as independent functions that can communicate with each other. Found it, let's ease it for you. Okay. You are a restaurant, there is a chef, your program preparing multiple dishes. Okay, so let's look at the code. So basically, what a Go routine is something that you can process in parallel. So let's just open Excel draw and let's just explain Go routine. Go routine. So let's just say that you have a huge video. For example, 10 gigabytes worth of video you have. Let's say 4 hours of video you have, and you want to transcode this video, and you want to use your CPU for transcoding. Okay, pretty simple. You have a 4 hour video which is pretty long, and you want to use your CPU for transcoding. Your CPU has 4 cores. Okay, your CPU has 4 cores, and you want to transcode. So what you will do is, this shit, भाई बंद हो जा क्या है नहीं चाहिए भाई ये. But so what you will do is you have 4 cores. So you will divide 1 hour in for each core and combine them in the end. So this is what you should do in ideal way. This is like pretty simple, pretty like this is like taking away all the complexity that goes behind it and just telling you what happens like pretty high level. because things are very complicated in between and how it works. So you need this thing. And transcoding is a very CPU heavy task. So the CPU don't need to switch between things. Because once a CPU is assigned to transcode a 1 hour video, it will not be free. Okay? It will not be free. It will keep on doing those things because it's a pretty long process. What is not a long process is accepting a TCP connection because there are delays in between. The data is not coming every time. A request might stop. So in this case, when you had a 4 hour long video which needs transcoding, you could have easily done it using 4 cores and dividing them in 4 cores and just doing 1 hour for each core. Okay. But if your task is not so CPU heavy, that means some CPU, some networking, some IO, and let's say some, okay, so this is everything that can happen basically. So let's say your CPU, your task that you want to do is not very much CPU heavy. Uh, you are also doing some networking in between, like accepting the connection, waiting for the connection to come, which is not CPU heavy. So if you go really deep, like how computers wait for a TCP connection, you would know that there is something called ePOL. So ePOL, what it does is it just notifies the CPU when anything comes there, when anything comes in the network stack of the operating system. So till then, the CPU is just idle. So what we need in this scenario is to optimize the core usage or the CPU usage. We want more than four for concurrency. So why we need more than four concurrency? Even we have 4 cores on my computer. So in the transcoding case, the CPU is pretty busy. It cannot switch. It don't have time to switch because transcoding is all CPU. Okay. So in this case, there is no need for more than four concurrency because that is the most you can do. Okay. But in the case of a networking program, for example, a reverse proxy, there are a lot of times when our reverse proxy, when our CPU will block the operation. So let's just look at our code and see. So this whole thing will run inside a single Go routine or this whole thing will be sequential and it will be run by a single core, like sequentially. Okay. So let's just see here. Okay. So this is the origin server. This is doing fmt.println. So what will happen here? Here, the CPU will give instruction to the console to print server started. So here the CPU will give instruction to the console or the screen to print server started. And in the meantime, when console will return like, hey, I printed server started. In the meantime, what CPU will do? So the CPU will stay idle there, will not do anything else. So that's why we need a lot of concurrency in this program because there are a lot of stopping points. So let's say this is also a stopping point here. Listener slash error is net.listen. So this what it will do is it will go to the network stack and ask like, hey, give me everything that is coming on the port 3000. And this will also block till networking stack of the operating system, networking stack returns. Okay. And here in the for loop, this is like literally blocking everything because let's say this block was, let's say, few millisecond, let's say 5 millisecond, which is also a huge time for a CPU. Your CPU can perform actions in like nanoseconds. So this is huge for CPU. This is huge delay and this is a huge wastage of CPU. But let's say this was 5 millisecond because it's pretty fast to print a console. Let's say this was 7 millisecond. And let's say that a new request, because the coming of request depends on the client. So let's say a new request comes in 2 seconds. So your CPU will wait for 2 seconds on this place on your code. So this is like years for CPU. You are wasting the precious silicon that is built from the core of the earth. You are wasting that silicon that was built by fucking 1000 technologies coming together and the peak of human innovation. You are building you are wasting that thing. So we don't want to waste that thing, okay? What we need is we need to use the CPU optimally. Like every time our CPU should be working like a slave to us. Every time it is working. Okay. So I just send the network request. Let me do another. Let me do another thing and just wait for it. Okay. So this is how your CPU should be, like a slave to you. It should be working 24/7. So let's just do some things now to make it work 24/7. And we will do those things by using Go routine. Okay. So let's just understand Go routine in detail. So there are also So this problem is pretty like ancient in computer way, like making CPU do multiple things. So for this, operating system have threads. So these are like a abstraction layer where you can run multiple tasks concurrently. So this OS also have threads which can run multiple tasks concurrently. And it also have cores, which are like physical cores. These are not abstraction layer. These are the physical silicon where your software is running. And OS have threads, which can be used concurrently. So let's say one thread is receiving the request, one thread is printing on console, one thread is talking with the database. So OS have threads. So why use Go routine? So why Go routines? Why? Why we need Go routines when operating system? So I'm currently using Linux, and there are like pretty good OS threads implementation in Linux, and I can use that. Why use Go routine? Okay, so let's just ask ChatGPT because it is pretty good at explaining things. Why use Go routine instead of OS threads? So till this is responding, let me tell you a basic reason why. The OS threads are of size megabytes, but a Go routine is of size 2 kilobytes. 2 kilobytes is a basic size, and if you are storing something in that Go routine or you are doing some things, it will increase the size, but you can create a empty Go routine for 2 kilobytes. But to create a OS thread, you need at least some megabytes of data. I don't know how much. So let's just apply a simple math and let's just say you want 1,000 threads, which is gigabytes of RAM. Okay. And let's just say you want 1,000 Go routines, which is megabytes of RAM. So as you can see here, if you use 1,000 threads, your computer will go down because it will like have all the RAM filled up. Okay, you cannot create 1,000 threads. I don't know if even if your operating system will allow you to create 1,000 threads. It will stop you before reaching the memory limit or the RAM limit. But a Go routine is just 2 kilobytes. So this 2 kilobytes of data multiplied by 1,000 comes in the range of megabytes. So for example, 2 megabytes of RAM for 1,000 Go routines, for 1,000 processors trying to process parallel things, it just take around 2 megabytes of RAM. So that's pretty good. You can even go further in here. Let's just say you want 10,000 lakh, 10 lakh. So if you even run 1 million Go routines, then it will come in gigabytes of RAM. If you run a million Go routine, it will come in gigabytes of RAM, which is pretty good for doing a million things together. And if you want a million threads, then you need the NASA computer for that, because you cannot do that in your laptop or in your server. So this is the basic reason why we need threads, why we need Go routines, and there are many more reasons why. Because this Go routine is also managed by. Okay, why doing this? So this Go routine is managed by Go runtime. Okay, so this Go routines are managed by Go runtime, and this OS threads are managed by obviously operating system. So there are some differences here. You can study about these differences. You should, if you are interested in like parallelism and everything, you should study about these things and at least give around 2 to 3 hours to study like why you should use Go routines and where you should use OS threads. There are some special cases where you should use OS threads, but where should you use Go routines? So let's see what ChatGPT gives. So why this Go runtime is better than OS runtime? It's not a thing of better, like it's not about better, but it's just Go runtime. So for example, your operating system is executing a program. This is your operating system, and this operating system is executing a program in here, which is Go runtime. And this Go runtime will manage all your Go routines. So each and every Go routine will come in this Go runtime, which is running on your operating system. So there is less context switch in the case of Go routine. You can study about what is context switch and how CPU like context switch between different programs and how threads do context switching. Like there are a lot of things to study. And let's just see. Okay, so the first thing that ChatGPT said is OS threads are expensive. This can be from 1 megabyte to 8 megabytes. So that's the thing that I explained. So Go routines are lightweight. Starts with a tiny stack, 2 kilobyte. Like you can create an empty Go routine using just 2 kilobytes. And if you run something in that, and then the stack will grow like incrementally. For example, if you run an infinite for loop inside a Go routine, it will go to gigabytes of memory. That's for sure because you wrote an infinite for loop. But it can start with 2 kilobytes. Okay, and M and N scheduler. So what this means is M means machine and N means operating system threads. So Go scheduler, 8 OS threads, 8 CPU cores, and 1 lakh Go routines. So these are like frameworks to explain like why Go routines are better. So I don't think that we should go too deep in there. You can definitely go too deep, and I have also like studied a lot about these things. But I think that this will be a waste of time for our reverse proxy thing. And blocking IO, yeah, that's pretty good. Faster context switch, yeah, this is also a pretty good advantage in favor of the Go routine because the Go runtime controls scheduling. Less CPU state must be saved. No kernel transition is usually required. So yeah, example reverse proxy. Okay, so that's why we are using Go routines. Okay. So now let's see how we can create a Go routine inside our code. Okay. So let's just see the syntax of the Go routine because right now you understand the concept of the Go routine. Now let's see the what the syntax is for writing a Go routine. So the syntax, okay, this is very cluttered and let's just make another file. Go routine.go. Hmm, package. Cache file, Go routine. Okay, so let's just talk about the syntax of the Go routine. maybe it will work when I do this. Yeah, because we are in the main, I guess. I don't know. I don't know about this thing. Like forget everything. Let's study the syntax of the Go routine. So let's say you want to write fmt dot println hello world, okay? And you want to write it again using hello world 2, okay? So in this case, what will happen is this will be sequential. First, this statement will be printed, and after that, this statement will be printed, okay? So let's just close the caddy server, and I had a terminal open just here. Okay, this is the main server running. Yeah, so this is it. We have the go routine.go, so it should run. Okay, so there are some errors here because I don't know if we can create another Go file in the main package. Okay, so let's just create another package for this thing. Let's just copy this thing, create a another folder here. Let's name them handlers because this will be handy afterwards. And let's just say handle request because it will come in handy afterwards. And let's just do this thing, remove it from here. Okay, so this looks good. Now let's just go to handler and let's just do go run handle request dot go. What the okay, it's not a main package, so we need to do that inside the main package, I guess. Okay, so I cannot run. Okay, so the Go program runs from the main package. So what we can do now? We can import this handle request here and okay, so yeah, we will do that thing. So let's just get to txt. Let's just remove everything from here and let us just copy this thing here and let's just do a save and handle request. Let's just copy from here and let's just do this. Okay, so this should run now. If this don't run, then we are cooked. Go run main.go. Okay, so this is running. So what you wanted to do is you wanted to print hello world first and hello world 2 afterwards. So this thing, it will do is this main thing will start in a Go routine. So everything in Go happens inside a Go routine. So this package main is also a Go routine. This main function is also a Go routine, not package main. Package main is just a way to describe the package name, but this function main is a Go routine, and it starts. And first of all, it prints hello world, and after that, it prints hello world too. Pretty simple, sequential way, no confusion. Everything looks good. Okay. So now let's just do these two things inside two different Go routines, okay? So let's just write Go here and let's just write Go here. Okay. So what this Go will do is it will create another Go routine and execute this code inside of that Go routine and create one more Go routine and execute this code inside of that Go routine, okay? So let's just do this. It did not work. Okay. That's pretty interesting. You know why it did not work? Because this main Go routine did not wait for these two Go routines to complete. That was the reason it did not print hello world and hello world too, because this okay, so what was the procedure for this main go routine to work? Okay, start, create a go routine and print hello world. So after this go statement, this thing is different from the main go routine. So it will go on a parallel go routine and it will start its execution. Like it will say to console, hey console, can you print hello world? And console will then print the hello world, and then it will go back to the go routine and say that the hello world is printed. So this is the process for this for this go routine. But the process for this main go routine is just create a go routine this, create a go routine this, and then end. So it did not wait for these two to complete. As you can see, these two are IO operations. Printing on a console is a IO operation, so it takes time. But creating a Go routine, it does not take time. So as you can see that your CPU is pretty fast. It's like pretty fast. So what we will do here is we will just sleep the main Go routine. So let's just see how to sleep a Go routine in Go. Yeah, just do this here. Okay, so let's just do this time.sleep. So what it will do is it will block the main go routine for 2 seconds. Let's just do it 1 second because I don't want to wait for one extra seconds. So as you can see, this happened here. Okay, so we waited for 1 second, and after waiting, these two consoles came. But this is pretty bad code right here, because you are literally wasting 1 second of the CPU. You can try to reduce this 1 second by going to 0.5, and okay, so it don't even go below that. So let's just do the millisecond maybe. Yeah, millisecond, and let's just try to sleep it for 1 millisecond. Let's see what happens now. It still ran fine. Okay, so let's just sleep it for less than a millisecond. But smaller than a millisecond, microsecond. It did not run this time. So we have to find a perfect time where this thing will sleep and it will not stop the CPU. It's between microsecond and millisecond, and we don't know that. Okay, we don't know what it will be. So there is this way to find out the optimal time to sleep the main thread so that the execution of these two things can happen. But there is another way to do that, and that is the channels. So after learning about Go routines, we will learn about channels, what a channel is, and how channels work. Okay. So I am even studying these things after a long time, so I can also make some mistakes. And another thing I wanted to show you, let's just do this thing. And yeah, millisecond is good. And let's just run it a load of times. Okay, so this came in the first part. Okay, so as you can see, go run main.go and hello world. So this hello world was in the second part. This hello world was on the second line of the main function, but it got printed first. So why is this happening? Why? Because the Go routine, the Go compiler does not guarantee the sequential order of things, because we are doing multi-threading and multi-processing. So guaranteeing a sequential running of code is like hampering the performance. So if we had waited for this code to finish, and then started the next Go routine, then what is the use of a Go routine? What is the use of a Go routine if we waited for the for the first line to finish and then we started the next line? So there is no use of a Go routine in that case. So that is why these two things happen in parallel, and you cannot guarantee that which one will be executed first or which one will be executed last. It's not a guarantee. So that's why we need channels. Why we need channels? To communicate between two Go routines and to transfer data between them and to avoid writing bad code like this and to ensure that if in some cases we need to ensure that this Go routine must run or wait till other Go routine is complete. There are many cases like that. So in that cases, we need a channel to ensure that the data from first Go routine should come and the first Go routine should complete before starting the another one. So for that we will use channels and now let's just study about channels. I hope the Go routine is clear to you. So let's just see the live stream, how it's going. Because this is going fine, this is going fine. Views, we have 3 views. Let's go, let's go, let's go. And uh, can I change moderation activity timestamp? Okay, so let's just close this thing because I don't want to interact with the chat. I just want to, complete the playlist. So what are channels? So channels are a way for a Go routine to communicate and synchronize their execution. This word is very heavy. Synchronize their execution. So what this means is it means the same thing as this. To synchronize their execution. And we don't need to sleep the main thread. So if there was a way for the main Go routine to know that the execution of the first Go routine and the second Go routine is complete, and then it can stop its execution. So if there was a way for this Go routine to send like I am done bro to main Go routine and the same for this one. If there was a way where after execution, this Go routine could send the main function like I'm done, bro. You can complete the execution. And the same for this one, like the second one. Like I'm done here, bro. You can complete the execution. Then the main will wait for the response of first and second and then complete its execution. So what the main Go routine will do then is it will wait like, okay, I'm waiting, I'm waiting. Okay, so the first one send a message. I'm done, bro. You can move on. So it will still wait. Okay, I'm waiting for the second. Second is taking a lot of time. Okay, the second send the confirmation. Now let's execute the program. Let's just complete the program. So that's how channels work. This is the need for the channels. I showed you this thing so that you can know that why we need channels. Without channels, we would be like guessing, okay, so what is the optimal time to stop the main Go routine so that both of these Go routines can complete? Okay, so let me guess. Is it 1 millisecond? Is it 1 microsecond? Is it 0.25966 millisecond? You don't know. Let's just return the Go routine like I'm done, bro. That's better. So that's why we need channels. Let's go here and remove these things. And let's just see what else the channels say. A channel is a data transfer pipe where data can be written into or read from. Our Go routine can send data to a channel, and another Go routine can receive data from the same channel. Yeah, I know. Let me explain in simpler. These are the simplest of words, bro. Who is this guy? Ashutosh Yadav? Bro, these are simple words. What you saying? So, yeah. So what this line mean is a channel is a data transfer file where data can be written into or read from. One Go routine can send data to channel and another Go routine can receive data from the same channel. Yeah, I know. Let me explain. Okay. So it's just simply that we can write to a Go routine and we can read from a we can write to a channel and we can read from a channel. It's just simple as that. And okay, so let's just move forward. And there are also two types of channel. So the first is buffered and the other one is unbuffered. And let's see if he explains them. Imagine you have two workers. Okay, we don't need like childish examples. Just tell us what a channel is. Okay, so this is the syntax for creating a channel. C make channel int. Okay, so let's just create a channel. Uh, क्या था भाई? Make channel and the type is int. Okay, so this is a channel, and this channel can be used to receive, to send and receive a integer value. So what we can do here is we can just create two channels and okay, so we also need to create a function for that thing because we need to do a lot of things here. Okay, so what was the way to define a inline function or a no-name function in Golang? Way to define a no-name function? Yeah, it's pretty weird. I'm not remembering the name for this, but let's just say no-name function in Golang. Func. What the fuck? Yeah. So this is the way. So why was it giving error before? This is correct. Yeah, let's just put this inside a inline function. It's still giving the error. What the fuck is expression in Go must be a function call. So maybe some parameters or something like that. Uh, okay. Hmm. Func. Okay, so this is the same thing as our. Okay. So what we need here is we need to execute this function, and because till here what we did was we defined a function, an inline function, but we did not call it. So what this brackets will do is it will just call this function. Okay. So let's just also write a same function for the second one. And let's just remove this line and let's just do this here. Okay. So why we created a function? Because we need to do more than one things inside a Go routine. So this, for example, this thing, go, and then you are printing something and hello world, and let's say you want to assign a variable. Let's just say variable, let's just say a string. So this thing will be done by this Go routine, but this variable will then come under the main Go routine. So that's why we need a function so that we can do multiple things inside a Go routine. Now we can do this here, and this will be done by this Go routine. Okay, so that was the reason that we created this Go routine. This var is giving error because this is like not a correct word to use. Let's just do something else. Yeah, it is not giving error now because var is a predefined like value in Golang, which is used to declare a variable, and we used it to declare a name of the variable. So that was wrong. Okay, so these are the Go routines, and now let's just study more about Go routines. So this is how you make a channel, and this is how you send a data to channel, and this is how you receive a data from a channel. Okay. So what we can do here is let's just create two channels. Okay. Um, C1 and make channel, and let's just assign it a bool value because it's just 1 byte. Okay. And let's just assign the second channel make channel bool, and this is also a bool value. Okay. So what we will do here is after the completion of this go routine, we will just send a true value from here. How to send it? How to send a value to send 42 to channel? Okay. So what we need to do here is we need to do this thing and true. Okay. And after this, what we need to do here is C1 true. Okay. And here we can wait for both of these channels. C1, CV1, C1, C2. Okay. So here we can wait for both of these channels to come a data. Like if the true comes here, this main go routine will wait till a true comes in both of these channels. So now let's just wait and see how to wait for a channel in Golang. How to wait for a channel in Golang. Okay, so this is the done channel. Execute block here until a value is received. Okay. So what we will do is, okay, so yeah, we will wait for C1 and we will wait for C2. And this is how our program will be. Okay. So this is the syntax to wait for a channel. It says just like wait for this thing. It is, yeah. So this is the name of the channel and it is just saying like wait till something comes here. And this is also the name of the channel and it just said like wait till something comes here. So let's just run this thing. Yeah. So this thing worked fine. We didn't need to like wait 1 millisecond on 1 microsecond. We didn't need to guess anything. Everything is synchronized here. And whenever both of our channels return, we just return the value. Yeah, so this is pretty good code. Let's just why hello world is always coming second. It should come first also. Okay, so this is pretty interesting. Behavior from Golang. Why is it happening? Why? Because once in a while, hello world should also come before hello world too. So, maybe this is taking too long to print. Why? Why is this taking too long to print? What is the difference between this and this? There is no difference here. Hello world is there, hello world 2 is there. So let's just reverse the things. Just write hello world 2 and hello world here. If hello world is coming second, if hello world is coming first now, then it's a problem. Okay, so this is a problem. Hello world is always coming first. Why? Okay, so go func execute this function, wait for C1 and which is hello world and wait for C2. Yeah, it should be. Okay, so let's just ask ChatGPT if this code is correct or not. Why hello world is always printed after hello world 2? Yeah, that's what I was saying. Okay, so so it is saying that our code is correct, and this is not a guarantee that hello world should print first and hello world like this should print first or this should print second. This is not a guarantee. So that was why I was saying like there should be a mixture of both of these things. Like it should be sometimes it should be first, sometimes it should be first, but it's not happening here. The second one, this hello world one, is always printed first. So I don't know what is happening here. Maybe like a CPU should have done some type of caching or something like that. So that is why this statement is always getting printed first. But there is nothing wrong with our code. And this is how, and now we have understood everything about Go routines and channels. And I hope that you guys, Pranjal Gupta, iski aana. Bro, I had come to see the reverse proxy. Bro, this is the art of coding. We will start from Hello World by making the Hello World parallel to making our reverse proxy parallel. So always start from basics, always start from first principles, and then you can move forward. Okay, okay, okay. Pranjal Gupta bhai, OP in the chat. Okay, so let's just not waste our time and let's just make our proxy, reverse proxy multi-threaded the same way as we made our hello world multi-threaded. Because if you understand something, then you can apply it to everywhere. I believe that if you like think from first principle and understand a thing simply, then you can go to a most more complex iteration of this thing. Okay. So let's just remove this thing from here and let's just copy the previous code which was present here and let's just do this. Okay. So now what we need to do? We need to make this reverse proxy multi-threaded. Okay. That's a pretty ambitious goal. So let's just make a function which we can call again and again using a Go routine. Okay. So let's just name it handle request and it will receive a connection variable. Let's just name it client connection. What kind of connection will it receive? Yeah, it will receive the client connection, and the type of variable will be this net.connection. Okay. So the type of the variable will be net.connection, and what we do now is we just go to main.co and just copy everything that is present here and just paste it here. Okay, so we need to do some things now. Um, just name it client. Mm, why is it still giving the error? Client connection. Okay, the C is not capital. Yeah, client connection. Client connection. Okay. So this origin server is undefined. Okay, okay, okay. Wait a second, bro. Wait a second. Let's just hard code this thing. Like, I don't care because we can always change this thing. And origin server hard code. And this error is giving error because declared and not used. So let's just use this variable. This error is not equal to nil, then what we will do is we will just we will just fmt.println fmt.println could not connect to main server, and let's just also close the main connection because that is a good practice to do. Okay. So what this is saying is client dot connection. Yeah, this needs to be correct. Hmm, yeah, इसको भी भाई ऐसे ही कर देंगे हम client dot connect. And now we have a handle request function that we can call using this go routine. Okay, so this is not used anywhere right now, so let's just remove this. Let's just also remove this log. Okay, so let's just keep this log, why not? And inside of this, if also let's just close this client connection if error comes. So let's just name it correctly because this will create some confusion afterwards. And after this, let's just close this connection. Yeah. So this connection is closed if error comes. Now what we will do is we will just, what was the name of the module for the handle request? Handler package name. Okay, so we will call handler dot handle request and we will pass the client connection here. Okay, and I think this should work now. So what we are doing here is we were sequentially doing everything here, but after coming inside the for loop, we are using a go routine to handle a single client connection. So for each get request we will process that get request inside a separate go routine. Okay, so let's just see. Everything is working fine. We have 9 views today, so let's go. The views are increasing. So what we will do now is go handle dot connect handle request and client connection. So each and every get request will be handled inside a separate go routine. Okay. So now let's just try running this thing because this should work now. Server started. Okay, we don't have localhost 3000. Okay, so our proxy is running on localhost 3000. And we just need to specify to this Firefox that bro we are okay, so this thing is running fine. Okay, so we made our reverse proxy multi-threaded by just simply writing this go thing here, but there are still a lot of inefficiencies in this function. There are still a lot of inefficiencies in this function. So what we will use is we will use io.copy to copy from okay, so let's just see what kind of variable it accepts. So disk io.writer, source io.reader. Okay, so it accepts a reader and a writer. Source to destination. Okay. So what my plan with this thing is, we will just remove this buffer variable from here and we will then this whole logic will be removed. We don't need any buffer variable now. And basically what we need to do is we need to copy data from this reader variable to this main connection. So we can just copy data from this reader variable to this main connection till end of line. So in computer science, this thing means that a line is ended. So it's something like slash r slash n. So it's something like this. If this thing comes, then that means that a single request is over. This is how like TCP protocol is. if this thing comes in your request, or if this thing came in my server, that means that a single request is over. So what I can do is I can just copy this request from here to here to this main connection dot write, and we can just copy and this io dot copy. Let me just also show you some properties of io dot copy. So this io.copy will copy until either end of line is reached or on source an error occurs. So it will copy by default till end of line. So it's pretty like convenient for us to do this. And also what in my mind is that we will use a go routine. We will use a go routine to copy from this reader to this main connection, and we will use another go routine to copy from this main connection to the backend proxy. So we will use two go routines inside another go routine, which is running inside a main go routine. So this is pretty like weird stuff, but it will give us a good performance. And I believe so it will give us a good performance, or either it will crash our laptop like before, and we will need to find another way to beat the caddy server. Okay, so let me just load test this thing because this thing is also not that bad. So let's just load test it, and let's see how where we are standing right now. Let's just not send 1 lakh request straight away. Let's send 1,000 requests. Okay, so let's go. It gave around 8,000 requests per second. Let's just increase a bit. Okay, so it is giving 8,000 requests per second. Okay, I'm being ambitious right now. I'm sending 1 lakh requests to my proxy. So let's see what happens. And I press the enter. Okay, let's see. Please, please, please don't break my computer this time. Please don't break my computer this time. Please, I don't want to start again. I don't want to restart. Okay, bro, this is crazy good. This is crazy good. As you can see, the request per second column. This is 9,000 requests per second. 9,000 requests per second. So this is like pretty good, pretty decent. Because other than using Go routines, I also have a few like more improvements in mind. So we are at 9,000 requests per second by just using the Go routines. Okay. So our previous one. So let's just write this here. Okay. So Cashify version 2 with Go routines is giving around 9,000 requests per second. Okay, so which is let's just divide this thing. 26 divided by 9. Huh? No, 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 no. We need to divide. Okay. We need to divide 60 divided by 9. So our reverse proxy till now is doing around 6.66. 6.66 times slower, which is pretty decent, I would say, for a reverse proxy that we built only 2 days ago. So yeah, it is pretty decent. And now let's just improve a few things also. And now I need to lock in because things can go wrong if I wrote some bad code here. And because if we send around 1 lakh request, and if I am doing around two go routines inside each request, so let's just multiply it by two, and we are doing so this is also a single go routine which will invoke these two go routines. So these are around 3 lakh go routines here. So these are around 3 lakh Go routines, which should not break my computer because 3 lakh means 3 0 0 0 0. So this is it. And if every Go routine is 2 kilobytes, then it is around, let's just add 5 zeros, 4, 5. So let's just remove 3 zeros and make it megabytes. So this is around 200 megabytes if I am calculating it correctly. So this should not break my computer or where I need to restart my laptop. But it can go wrong because this is the bare minimum. So 200 megabytes is bare minimum. And if I wrote some like things in my Go routine which takes up memory, and if I made a single Go routine from 2 kilobytes to 10 kilobytes, then nothing will happen. Yeah, it will take around 1 gigabytes of memory. So now let's see how much memory I have on my system. Okay. So I have around 1.6 gigabytes of memory available. So this is pretty low. So if I turn this 2 kilobytes into 16 kilobytes, then my laptop is over. Then I would need to restart and this whole thing will be done. So I need to be careful. Let's just double check the math with ChatGPT. Okay. So 3 lakh Go routines, memory consumption. What the fuck? Okay, so our math was wrong, bro. Our math was wrong. So 10,000 Go routines will take 20 megabytes. And what kind of math we were doing? So if we did 3,000, 3 lakh request, then we will take around 600 megabytes of memory. And this is the initial stack. So if we use anything inside a Go routine, and if we by default double this initial stack to 4 kilobytes, then we are done. Then we are almost done because let me show you the available memory on my system. Available memory is around 1.6 gigabytes. So I think that we will need to restart our laptop if this happens. So yeah, it's pretty risky, but like fuck it. Whatever happens, happens. At least I am on Linux, so this should not stop. This should not show any unexpected behavior. And I am like confident in going to that because I am on Linux. And if it was Windows, it could have crashed way earlier because like my laptop is pretty old and it's the Windows does not run on it well. So let's just do that thing. Let's just log in for a minute. Okay, so this is the buffer that we have. Let's just remove this buffer and let's just remove this thing also. And remove this comment. Okay, and what this is doing is it's calling the main connection. Now what we need to do is main.write. Main.write. Okay, so let's just do io.copy and let's copy from this reader to this main connection. Can we do this thing? No, we cannot do this thing. Buff IO cannot use reader as IO writer value. to io.copy does not implement write missing method right. Okay. So this is a reader and we need a writer. But we need to read from this thing. So how this thing io.copy works, let's see again. Okay, so we need to pass the reader in the second parameter. So let's do that. Let's pass the main connection first. And this. Okay, so yeah, it is working. Okay, so let's just also remove this thing. Did I remove something else? No. Remove this thing. And let's just main connection data read back into proxy. Okay, so back into proxy. What is happening here? This will just gain the number of bytes read. And here we will again do a io dot copy. And what we will do here is we need a writer first. So we are writing to this thing. So let's pass it first. And we are writing from backend to proxy. So which is main connection to reader. Okay, so which is the client connection. Okay. This is the client connection we need to write for the final request, and we need it from the main connection. So yeah, I guess this should work now, or it should not. I don't know. I don't know. So why are we even taking this reader? We can just pass these two connections. And let's just remove this thing because we can pass these two connections here. So we don't need this thing. Okay, so let's see what happens. What is happening? Uh, Copy from here to here. This is the reader. So this will read from the client connection, copy to the main backend connection, and after this, this will read from the main backend connection, and this will copy to this connection. Okay, okay. So this is pretty good, I guess. And let's just not use the Go routine right now because I think that let's just see if this thing is working because we don't know if this thing will work or not. HTTP colon slash slash localhost 3000. This thing is not working. This thing is not working. There is some error here. Okay, so this thing is not working. io.copy. Can we just okay? So this will be sequential, and it should wait, I guess. Oh, is there anyone on the live stream? Bro, visual is boring. इसके boring. Life is 90% boring, bro. हाँ, ज्ञान फैल के चला गया आया ज्ञान फैल के चला गया ये क्या है भाई ये कैसे व्हाट इज दिस बिहेवियर ब्रो व्हाट इज दिस बिहेवियर इसको बैन करो चैनल से वाह यार 11 भी हो गया आज तो अभी कोई देख रहा है अभी तो कोई नहीं देख रहा तीन एक बंदा आया था 6:20 पे देखने के लिए ओके एक एक बंदे ही आए थे देखने बंद करके चले गए चलो भाई ठीक है इट्स ओके भाई इट्स ओके क्या ही फर्क पड़ता है सो अपना ये कोड क्यों नहीं चल रहा क्योंकि हम मेन कनेक्शन में क्यों नहीं चल रहा है? कॉपीज फ्रॉम सोर्स टू डेस्टिनेशन until एंड ऑफ इज अचीव्ड। सो इसका सोर्स क्या होगा इसका? इसको ना एक काम करते हैं, रिवर्स करके देखते हैं चलेगा कि नहीं चलेगा। मुझे लग रहा है यही दिक्कत है। इसका सोर्स सोर्स ही उल्टा कर रखा आपा ने। मेन कनेक्शन और अब मेन कनेक्शन से भेज दे क्लाइंट कनेक्शन में। ओके सो लेट्स ट्राई दिस थिंग एंड भाई एक तो बार बार एच टी टी पी जो लिखना पड़ता है ना, जो नहीं चल रहा अभी भी। ओके सो दिस थिंग इज नॉट वर्किंग। So let's just ask ChatGPT, what are we doing wrong here? So I dot copy, let's just copy this handler and paste it here because there I guess we are not closing the connection. Calls execute sequentially, not concurrently. It copies data from client to it does not return until the closes the connection. Okay. Okay. Response never gets sent to the client while the first copy. Okay. How can I be this dumb? Okay. So what is happening here? So this line, what this line is doing, when I send a request from my browser to the proxy, this line is copying that request from my browser to that proxy. Okay. This thing is pretty simple, but the browser expects a response till it closes the connection. Okay. So the browser expects a response from us. Like the browser send get HTTP 3000 blah blah blah. And browser is waiting like yo bro, I just send a request is coming back. But a request never come back. We are just copying this data to the client connection, to the main connection. And this thing will not start. This thing, what this thing is doing, this thing is sending the request to the browser. But this line will not execute till this line is executed because this is currently in sequential order. So this thing, this line will not execute till this line is executed. So that is why we were seeing this error in this. So let's just see. Um, so handle returns immediately and nobody closes the connection. Okay, so handle request, what does he mean by handle request? Okay, so what this thing is saying is, um, so if error is fmt.main.close and we need to do a return here. Why we need to do a return here? Because if there is a error while connecting to the main connection, then what we were doing? We were could not connect to the main server. We were main.close, closing this, and we were not returning this function. And if we did not return this function, this will come here and it will just wait for the data to come. So this will lead to resource leakages. It will just uh, keep on waiting for the data to come and try to copy this data. But this data does not exist. And we have already, we are done for this handle connection. If this error comes, we cannot do anything. So we need to return here. And now let's just use a go routine here instead of this thing. And let's just start. the server. Still, it should not work because HTTP and it's the main server working. Yeah, it's working fine. Is the 3000 working? No, it's not. Okay, so still there is some error in this. So what is the error now? Let's just see the chat GPT. What did it say? Only after it returned does the io.copy start or an error occurs. Okay. Okay, so maybe, yeah. So this thing is like pretty bad because what is happening here? What is happening here? Yeah, yeah, yeah. So what is happening here is this is the handler function which is running inside a Go routine, and the Go routine here splits. There is another Go routine that starts here that is trying to copy this copy from the client connection to the main connection. And another Go routine is started here and it is trying to math main connection to the client connection. Okay. And after that, we are not awaiting for this Go routine. For example, in JavaScript, if we awaited for these Go routines to complete, then it would have been better. It would have worked, but there is no await in Go. So what we need to do now is we need to use channels. And without waiting for these two to complete, it is just doing client connection dot close, which is closing the connection, and which is main dot close, which is also closing the connection. So the browser responded with this, like looks there like there is a problem with this site because there was no connection. The browser tried to open a connection, and my reverse proxy just say fuck off. My reverse proxy just ended the connection right there. So the browser is complaining like a bitch. So let's just try to improve this thing. Let's just wait for these two Go routines to complete before closing the connection. To do that, how we will do that? That is why I showed you the channels part because it is same as that thing, just same as that thing. And Pranjal was saying like, why are you showing hello world here, bro? Because consoling hello world concurrently can be used as because the concepts remain the same. Why is this? Okay, so we did not call this one same as before. Also, let's just do a func here and use a go routine here and just copy. Let's just call it here. Okay, so now what we need to do is we need to create two channels now. Okay, so these two channels will be the first channel. The first channel will be okay. The channel one will be make channel and the type, let's say bool. And now let's make channel two, which will be make channel bool. Okay, so there are two channels here. And what we need to do here is we just need to channel one to return. What was the syntax for that thing? चैनल वन में हमें भेजना है ट्रू। ऐसे था क्या सिंटेक्स या उल्टा था? उल्टा होगा। Yeah, so this was the syntax and the same for channel 2. Okay, so same for channel 2. And now let's just wait for both of these Go routines to complete. So how we waited for them in the previous one was channel 1. channel 1 to complete. Just use this thing, I guess, and the same thing for channel 2 to complete. Okay. So this should work now. This should work. Uh, let's see. Um, let's see. Yeah, let's go. Our implementation of the reverse proxy with channels and go routine is working. Now is the time for the test of the ages, the battle between Cashify and the caddy. The Cashify that we built day before yesterday and caddy which is there from the ages. So now let's just start this battle and load test the Cashify again. So let's just start with 100 requests. Easy for the Cashify. Let's just start with 1000 requests. Easy, 27,000 requests per second. Easy. Let's just start with 10,000 requests. Easy. 35,000 requests per second. That's crazy, bro. That's crazy. Just do 1 lakh requests per second. Oh, क्रेजी हो गया भाई क्रेजी हो गया क्रेजी हो गया भाई क्रेजी क्रेजी हो गया भाई क्रेजी so Cashify with version 3 no copy and pipe we are like creating a pipe between these two connections so let's just say pipe method and what was the request per second 43K per second which is crazy bhai crazy now let's just open the calculator and let's see the comparison now so the first we need to divide it with 49,000 requests per second 49 divided by 43 1.13 times slower 1.13 times slower okay no I did the wrong division अरे बहन we need to divide it with 60,000 now so let's just divide it with 60,000 43,000 request divided by 60,000 अरे भाई पागल हो गए हम तो divide by 43 1.4 times almost slower so this is pretty cool I guess 1.4 times slower so we officially beat caddy in this competition. The caddy server was going around 26,000 requests per second, and our server is going around 43,000 requests per second. And this is pretty cool because yesterday our server crashed and it was doing like 49 requests per second. So it is pretty like heartwarming to see this thing. And I still have some more improvements in mind for this thing because there is some things called as channel buffered channel in Go routine. So what a buffered channel is? So what is happening here? Let's see again. This Go routine is started and this channel is also started. And what happens now is this main go routine will wait for this channel 1 to accept this true variable. So this channel 1 don't have a internal storage because it is a unbuffered channel. So it will wait for the main channel to accept my true. Like it will wait like please, please bro, accept my true, accept my true. Okay, my true is accepted, execution ended. So it is going to wait for that. This will not be a huge wait. This will not be a huge wait, but it is still a wait. And we can maybe improve like 2 to 3,000 requests per second with this improvement. And we will also make the same improvement for this one using the unbuffered channel thing. And I also have another improvement in mind. And this improvement is also pretty huge because this one, I don't know if this will improve the performance or that much, but this will definitely improve the performance. So what we are doing here is we are doing an infinitely for loop, and inside this for loop, we are calling this handle request function. And inside this function, we are dialing a TCP connection to our server. But but there is idea. There is a thing called as connection pooling. Connection pooling. So what connection pooling is? What connection pooling is? Let's say we have this net.dial. So right now, what is happening? If my proxy server receives around 1 lakh requests per second, so there will be 1 lakh connections made. So there will be 1 lakh new connections made and closed because we are making this connection here and this connection is closing here. So we are making around 1 lakh new connections and closing them. This is not a good thing to do. And we can improve in this thing by, let's just say, having a pool of connections. Let's just say we have 1 lakh connections, but we reuse them every time. So this is a pretty good idea. If we can like execute it right, it can improve our performance even more. Like even I think that we can I think that we can even reach around 50,000 requests per second. And reaching 50,000 requests per second with Golang is pretty damn good. Because the best proxy in Golang is caddy, which we defeated already. And the next proxy to defeat will be Nginx. And Nginx is written in pure C and C++. It is the most performance proxy in the world. And we cannot defeat a C proxy with a Golang proxy. That is just not possible. So we already defeated our competition, but we will implement this thing in the next video, this connection pooling. We will have around 1 lakh connections, or maybe not 1 lakh, maybe some less connections. I will search about connection pooling and how to do this thing. And you should also search and see like what connection pooling is and how we can achieve connection pooling in our reverse proxy. And also we can achieve connection pooling because there is only one main server that we need to connect to every time, which is this. And we cannot achieve connection pooling for client because client is changing every time. Like we don't know from where we can get the request. We can get the request from India, we can get the request from Germany. Maybe I am searching for their server, or maybe someone else is searching for their server. So that is why we cannot use connection pooling for client connection. But the main connection is only one. Or maybe when our proxy increases, it may be 5, 10, 20, 100, but they are n. N means fixed. So we can always use connection pooling for this thing. So in the next video, we will talk about connection pooling more, and because these videos are just like I do not prepare for any of these videos and we just figure out things together. I just have some knowledge and some Go knowledge and some operating system and some knowledge beforehand that have stored in my mind, and I just like come here and review the things together. Like for example, we reviewed Go routine together, we reviewed channel together, and then we try to improve our reverse proxy. So I guess bye guys. And today our stream did not end like yesterday. And our code is, I can say that it is a bit improved. And we have two more improvements to made. The first one is the connection pooling, and the second one is to use buffered channels. Okay. And if you have any doubts or if you have any video suggestions, leave them in the comment section below. Okay. So bye. कोई है भाई